我是怀怀。 So, welcome to Siddharth Bisht. He is an associate data scientist at IBM India, and he is going to present you the age of reason, shifting from pattern recognition to logic and understanding. Welcome, Siddharth.
Hello, good evening, good morning. I really don't know the time, but first of all, thank you, UT Vance, for actually organizing this. So I'm yes, first of all, I'll remove this meme. I'm actually a associate data scientist at IBM GBS India, and today I will be talking about how we are making a shift when it comes to machine learning and artificial intelligence from pure pattern recognition, pure statistical learning, to actually understanding the logic and developing reasoning capabilities within the models itself. So first of all, what exactly is AI? Now, a few of you, I don't know whether you people were active on Discord. I shared this image So this is actually a drawing, not a drawing. It is a creation by an artist who goes by the name of Mario Klingemann. He used generative adversarial networks, which are basically a kind of artificial intelligence model that can be used to create new images, generate new images. So he created an artwork, and that was what I shared. Coming back to the point of what exactly is AI, now the thing is that even I don't know what exactly AI is. The reason being that there are two different ways to look at it. One is the one that the media tells you, or the hype that, oh my God, artificial intelligence, it will take over the world. It is superhuman capability, doing this, doing that. And then one is the theoretical, research centric, industry centric view of what actually we mean by artificial intelligence. Now, if you think about industry, for them, artificial intelligence is basically the capability of automating your tasks, most of them. How we do, whether it is, if you have a bunch of documents, right, and you want to identify which document is legal, which document is not, and you have millions of those documents coming every month, every week. So tasks like those, where you are supposed to automate task that has been done, is being done manually since the last 10 to 15 years, those tasks actually come under artificial intelligence because you're automating something that can easily be automated in the first place. Then is the research centric view. And to be honest, for them, we don't have artificial intelligence as of now, because whatever we have, it is pattern recognition, right? You have bunch of data, huge volume of data, and you basically try to find patterns within them. And hopefully, somewhere you get an inspiration like, okay, that makes sense. And that is what we are going to use. So when I say what exactly is AI, well, I'll show you this video. That is certainly not AI. But actually, I don't know. It could be in the future. Well, it could be, who knows? But that is certainly not what we have today. So when we talk about artificial intelligence, it is made up of two simple words, right? Artificial and intelligence. Artificial, something that is not natural. So artificial flavorings, artificial fruits, artificial love. So anything that is actually not natural, right? It is created, it is simulated, and it is all basically emulation, right? Imitation. That is artificial, right? It was not innate. Intelligence is basically your capability. Now, intelligence is a very difficult term to define because there are different levels on the basis of which you can actually categorize intelligence, right? There is spatial knowledge, whether someone is actually able to understand the shapes. Then there is verbal reasoning, whether someone is actually able to communicate, right? There are different forms of intelligence. Then there is aptitude, mathematical intelligence, reasoning capability, logical capability, right? So intelligence, uh, uh, I'll be using Francois Chollet's definition. He is a scientist, research scientist at Google, and he wrote a very good paper on the measure of intelligence. One thing I would like to point out that there are a lot of references in my talk, and I will be listing them out towards the end in the bibliography. And once the deck is shared with you, I insist that you all go through them if you are interested. That is important. Only if you're interested, because these are heavy duty stuff. They are really interesting, but they are time consuming. You will be needing some patience to actually read them. So in his paper on the measure of intelligence, he defined intelligence, because if you are going to say that, okay, this is artificial intelligence, you need to know what exactly is the parameter. How do you set the benchmark, right? How do you benchmark in the first place that this is artificial intelligence, this is not, right? So he defines it that intelligence of a system is a measure of its skill acquisition efficiency over a scope of tasks, right? How do you acquire a new skill given that this is a task with respect to priors? And when we say with respect to priors, what we mean is with respect to previous knowledge that has been gained, right? The beliefs that have been set, the ability that, okay, if I look at the above, most probably there would be a sky, right? And if you're inside a building, that is a different case. And then with respect to priors, experiences, and generalization difficulty. Now, what we mean by generalization difficulty? Generalization actually means that you should be able to do and you should be able to work with stuff that you have not seen before, right? So when we talk about generalization in case of artificial intelligence or machine learning, what we mean is that the model should be able to understand and work on the data that it has not seen before, right? And we usually judge its performance, the capability of the model on this particular data only, how well it generalizes. And there is a beautiful theory, we call it well, technically it is called statistical learning theory, but the VC dimension, and there is a lot of good work that has been done, wherein they actually prove that the way machine learning has been created, is done, we achieve good generalization up to a certain level. And within that level, there is a capability of underfitting, which what it means is the model is very biased, right? It is only for focusing on a few points, right, or very few elements when it is actually making a decision or making a prediction. It is only looking at a few set of dimensions or features, as we call them. And there is a case of overfitting, right, that it is not even looking at anything. Underfitting, okay, I got confused, sorry. So what underfitting basically means when we talk about generalization, it means that it is not able to properly map the function that we are trying to estimate. I'll explain what exactly we mean by mapping the function in the next slide before I define the dimensions of intelligence. But to recap this, so if you want to actually define intelligence, it is basically a measurement of skill acquisition capability on top of the task that you're doing, given that what all prior beliefs you had, what was your experience, and how difficult was it to actually generalize to this capability. In the sense that if you have never ever had an experience with water, and suddenly I say, go jump into the water, go swim. That is a very difficult task, right? Because we have never encountered it in the first place. So that is what we mean when we say generalization difficulty. How easily you can take the knowledge of one task and use it to do something that you don't know anything about. So there are basically, I have defined these, there are 7 dimensions of intelligence when we talk about artificial intelligence. The first one being knowledge. You need pre-existing knowledge, right? You cannot push a model, right? You cannot just say that, okay, give me this output, predict this thing. These are the features, this is the height, this is the weight, tell me the body mass index. Well, that is easy because it is a direct formula. But let us say that this is the, okay, you want to predict the calorie intake of a particular smoothie, right? So this is the protein count, this is the protein percentage, this is the carbohydrate percentage, predict it. Now, it does not know anything, right? It has got no prior knowledge. How will it do prediction? How will it predict in the first place? So that is what we mean by knowledge. You need a predefined knowledge bank. It needs to develop that, right? Then we have spatiality. When I talk about spatiality, what I mean is spatial knowledge. Spatial knowledge, 3D knowledge of the world, right? How you are interacting with the world around you. So three-dimensional stuff. Basically, computer vision is what we talk about, human perception, right? How do you see things? How do you walk? Whether you are actually able to move your hand and things like that. These are your spatial information, right? Understanding the world around you. Then we have synthesis. Now, synthesis is a tricky thing, but if you want to understand it in simpler words, it basically means it corresponds to understanding and communication between various bodies and components. So if you're trying to communicate with me, you're synthesizing whatever I'm saying, right, to actually understand. So synthesis, when we talk about that, what I mean is natural language understanding, speech, and even sensory stuff, right? If you give me a slap, I should be able to understand that you have actually slapped me in the first place. Then we talk about reasoning ability. Now, this is important because now you have a knowledge bank, right? You know the different aspects of the world, how they are connected to each other. You know the spatial information, right? Where they are located, how far they are from you. Then you can even interact with them through synthesis. Now comes the reasoning ability, whether you can actually make decisions based on this knowledge that you have, right? Then we have abstraction. Now you have a particular domain knowledge with you, right? You can interact, you have decision making capability. Now, can you transfer this ability to do something else, right? Can you abstract this concept out, that thing that you have learned, and use it in principle to do some other thing? But the process remains the same. Then we have simulation. Now that they have the capabilities of abstracting, reasoning, and understanding with the knowledge that they have, can you simulate a new environment? Can you create something that you did not think existed before? Right? This is what we call generalization. Can you generalize it? And if you think about it, we all simulate scenarios in our own head, right? We all create events. and we work on them. And the last part being evolution. Now that you have reached the highest performance, right, capability that you have, can you do something more? Can you transform into something else? Can you evolve into something completely different, right? Can you compress the knowledge that you have and use it in some other fashion, right? So these are the 7 dimensions of intelligence that I have defined for this particular case. Once we have that, then comes the blunder that media plays. Not that. Currently, there are 3 eras or ages of artificial intelligence that have been defined. This slide has been taken from David Cox's presentation at MIT, which he gave for a particular course, Introduction to Deep Learning, last year, 2020, in January. So uh, there are 3 almost ages. The first one is the narrow AI, or what we have done in the last 10 years. And when we say narrow, it is very focused, like a particular thing that we are going to do. So we talk about a single thing that a model can do, right? So we talk about a single task, a single domain, and since they are only doing a particular thing, right, they are only classifying images, they become, they have superhuman capabilities, right? Like, the model knows what a dog and a cat is. You can't tell that. Well, there are some outlier cases, but that is something that we can talk about later. So that is what we had till now, right? We were super focused on doing one thing properly. Now, 2021 onwards, we are shifting. We are going to a domain of multitasking capability. That means a single model should be able to do multiple things. And when we talk about that, what we mean is there should be a backbone system, right? This is usually called as feature learning or feature representation. And this is what is actually used in industries, right? They cannot have multiple models. You cannot have a model for this thing, you cannot have a model for this thing, because it requires retraining. You have to train them over and over again, and the data, there is drift, knowledge drift, and it is just not feasible, right? So usually what you do is you have a backbone system, right, from which you have smaller modules, right? So this backbone, what it does is it tries to learn features from the input that you give, the data that you give. It tries to learn the representation of it, what kind of information it is, and then it processes on top of that, making the task easier. Now, the thing is that most of the stuff that you're seeing around, if you are aware of GPT-3 or if you have heard of GPT-3, GPT-2, and all these stuff, these are actually backbone models. Why? Because they are representation learners. We will talk about that in the next slide, what exactly we mean by representation. And then we have explainable and distributable AI. Now, the thing is that artificial intelligence, we don't know why it does what it does, right? I give you an image and it tells you it is a dog, how did it do that? How did it know that it is a dog? Like, if I'm showing you my hand, the system will be able to identify, okay, this is the hand, but how does it know what is happening inside this model that we call the so-called model, right? So we are actually trying to understand that, breaking into we call it the black box, because we don't know what is happening. So we try to break into the black box. We try to understand what is happening. Why is it saying that this is a cat even though this is a black dog? There are cases like that. And once we understand, we shift from a single accuracy or single task to actually multiple tasks, a single model. We move to the general AI, where we can actually use one thing in another place. And autonomous, what is the word? Uh, I would not call autonomous vehicles because they're almost there. Like Tesla is very good in that way. There is autonomy, right? You have more robots. I would not call robots entities that can actually make decisions, that can actually do things for you, right? So we will be moving into that, but that will take at least 10 to 15 years more. So 2030, 2040 onwards, you will be seeing that more and more. Electrical vehicles, autonomous driving cars, trains, buses, and all these things, they will be a reality sooner or later, but they will be. Now that I have said that, there, now we will be going to the basics and the foundations of a few core concepts. Neural networks have actually become a standard computational tool, but what makes them powerful? And here comes the idea of the function and the feature that I was talking about. So there are 2 very important concepts. One is universal approximation, and the second one is feature learning. Now, universal approximation, I like this term because it is a very beautiful term. Approximation. So, what has been the idea of statistical learning, machine learning, AI, all these times that we have done? You have a data and you want to get a certain output, right? You have input and you want a particular output. Now, we assume that there is a function that takes in this input and gives me this particular output, right? What machine learning tries to do, artificial intelligence, I'll be using those terms anonymously currently, they try to approximate this particular function that can take this input and give you exactly this output. There will always be errors, and the learning is basically trying to reduce the output that the model gives you, right? Because you want the output of the model to match the real world output, right? What exactly is the truth, the actual truth, right? So when we talk about universal approximation, we mean that being able to approximate almost any function. And neural networks are capable of doing that. They can literally approximate almost any function that is out there, given that there is a pattern in the data. If there is nothing, no matter what you do, no machine algorithm will give you anything. So if it can seriously give you random stuff, right? That is the power of universal approximation. And then there is feature learning. So uh, what exactly is a feature? Now, if you look at me, there are multiple features, right? My face structure, whether it is circular, that is a feature. How many eyes do I have? There are two spiders. I don't know how many, but they have more than two eyes. So that is also a feature. If you're trying to classify whether something is a human or something is a spider, then number of hands, limbs that I have four limbs. Spider has eight, right? So these particular things are actually features. That means that given an object, how can I represent it, right? A combination of what? And you can actually represent a human by a lot of things, right? And all those things become features. Neural networks by default are feature learners. Why? Because they take the data and they work on them. And since we have layered structure, they try to from how can I define this? Neural networks are actually layers, right? So when we say network, you have multiple layers of neurons, right? And information flows through all of them. And at every layer, you have a mapping from the input to that. Because what you're trying to do, your neural network, it will take the input, it will give an output, right? Every layer takes the input from the previous layer and gives you the output. So what is happening at every layer, you are actually getting a representation of the input itself. So throughout the layers, information flows. And that is what you can actually see on the screen. This is a visualization of a neural network, of a very simple neural network. And these are basically layers, right? How the multiplication is happening, how information is flowing from every single layer of the neural network, and how output is actually achieved. So what neural networks try to do is they try to learn the features. They try to learn, right? Because if you give an image, it will try to learn whether there is an eye or not. What does an eye actually look like? Or whether there is a curve or not if you're actually going for facial recognition, right? Where there is a nose structure or not. So they try to learn these features, right? Having said that, these two are very important features. Let us move on to the main part of the topic. There are four things that we will be talking about. The first one is the brute force in the decade that was, right? What all has actually happened in the last 10 years when it comes to AI. And you people must, I think so, you people must have heard about most of them, and we will be quickly revisiting them. So actually we understand how it is all possible today. Initially, back in the 1950s, like AI and statistical learning, they have been there since 1955, but then we did not have enough data or computational power, which we call compute. Now we have that, it is easily possible. So we are seeing performance that like never before. So there are six key ideas that I've actually taken up. First is natural language processing. So natural language processing clearly saw a very big boom thanks to a particular term which we call transformers, or GPT-3, if you have heard it, OpenAI, and and Google Brain, especially, and Facebook. They have done commendable work, and IBM too for Watson. They have done a great deal of work when it comes to natural language processing. So now we are actually able to understand, not understand, but the chatbot that you see, or being able to search something very easily, question answering ability, that has actually increased drastically thanks to the work of thanks to GPT-3 and all. Then we also saw improvement in generative systems. And what I mean by generative systems is being able to create something new, right? Being able to generate, literally generate and synthesize something new. NVIDIA was able to create a particular, there is a website known as This Person Does Not Exist. The faces that are generated every second or every time you send a request, they are new, they don't exist. That was due to the work that was done by Ian Goodfellow when it comes to generative adversarial networks and autoencoders. And this was also possible due to neural networks, right? So we were actually able to create new images. And this is a very big thing because this is now used in video conferencing, right? Since they generate images on the fly, right? For example, if I'm talking to you right now, I think this is there in, I don't know, NVIDIA is working on this most probably. So what they have is, if I'm talking to you right now and there is a bandwidth issue, right? Data, internet is a very big problem. What they try to do is they're trying to recreate the image on the machine, and they are, instead of sending the data through the network, right? They compress it. They try to find the points that are needed to actually regenerate my face, and they will regenerate my face on your machine. So they are actually increasing the efficiency with which information is transferred. And since you are not transferring the video directly, you're compressing it, nothing is changed, and your face is being generated on your machine, right? So quality, video quality, there is no doubt about it, because it will always depend on your machine and system. So you can actually get HD quality irrespective of a bad network connection. Then we have computer vision, CNN. I mean, where is it? Your phone can now actually identify the faces and everyone, right? If you focus it, you can see the faces, automatic clipping and all. So computer vision, I mean, CNN was the first thing that took the world by storm in 2012, 2013 or 14, roughly, when Jeffries Hinton AlexNet came up. They were actually able to perform very well. That is again a research topic. Then we have three: edge machine learning, reinforcement learning, and graph learning. Now, I quickly cover them up because I need to move on to other important topics. So when we talk about edge machine learning, what we mean is your models are very heavy. How can you make them compact, right? Your phone also has machine learning models. It does not have that much, well, technically now it does, but there are smaller components, right? For example, a car and all, where you don't want to compromise with a lot of things, right? So how do I make my models compact? How do I increase the processing efficiency and stuff like that? Reinforcement learning and graph learning, well, reinforcement learning is the closest thing that we have to actual intelligence, because it is a decision making paradigm. You will usually see this in AlphaGo if you have heard of it, right? And mostly if you have automated AI based games, right? Reinforcement learning is what applies. So it tries to make a decision like, okay, if I'm here, if should I go and eat a chocolate given that I'm hungry, or should I go and sleep, right? So how do you make a decision such that you get the best output, right? You get the best outcome. And graph learning, most of the data in the world is actually in the form of graphs. So how do you actually understand information in that, be it chemicals, social networks, Facebook? All their data is actually in graphical format, right? How do you extract information from graphs? Because traditionally all this information is in a single vector, right? You have comma, 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 height, comma, hair color, comma, eye color, and things like that. But graphs, chemical compounds, are different. How do you actually understand them and interpret them? That being said, I skip this particular part and jump straight to the opportunities that we have in AI right now. So one thing that we actually have is fluid intelligence. And when I talk about fluid intelligence, what I mean is currently your model or whatever you see, your computer vision stuff, if you see, facial recognition system, they are good as long as they have the data. If something changes, they will not be able to do anything out of that. So when we talk about fluid intelligence, there has been work done on that. IBM has done that, neurosymbolic AI they call it. And current recently, I mean like 2 3 days ago, people from some universities they came up with the liquid neural network system. So when we talk about fluid intelligence, it is intelligence that can actually be molded. It can be shaped, unlike the fixed knowledge that you have. Okay, I'll train, I'll learn, I'll study. That is something that we all do, right? For exams, I'll study, I'll mug it up quickly. That is you're crystallizing the knowledge, and then you go and vomit everything on the exam, on the day of the exam. But what we mean by fluid intelligence is the intelligence that grows over time, intelligence that is shape shifting, right? You can change it, you can update it. Now, if you remember the talks in the morning, right, that were given by Mathis and Mike, they talked about privacy, they talked about cybersecurity. Now, the thing is that it is being incorporated in machine learning. Why? Because your data is important, right? You cannot be like, okay, take my data and predict whatever you want. You will not want that, right? And since security and privacy is a very big concern, we are trying to work on that. How can we actually encrypt your data and use that encryption itself to perform that modeling, to perform the task, right? To learn something instead of working on your actual information, because that is dangerous, right? Now that machine learning is capable of so much, anyone's data, private data, can easily be exploited. Multi-domain and multitask, I've already discussed. Capabilities of doing more than one thing with the idea of a backbone model. AR and VR is something that is actually really up and coming. So being able to synthesize 3D figures, generate them on the fly. I mean, your faces are also generated, right? Machine learning is doing a very big part there. That is an open field, and I think you all should definitely take a look at that. And the final two are quantum computing and centralized machine learning. Now, quantum has received a lot of hype recently after it was shown that there is a possibility that we can do things with this, right? And quantum offers you a completely different way of computing things, of programming, I would say. I am wrong in certain directions because I'm not quantum computing researcher, but it is actually opening doors for us. For example, problems like combinatorial optimization that was not possible earlier. You must have heard of the traveling salesman problem. People are working on that, and all the there are certain classes of problems in computers in general that are actually thought of to be very difficult to solve. Right? We call them the NP problems, NP hard, NP complete, and all those. Right? There is a possibility that we might be able to attack them. We might be able to cater to that need because they are exponential. The complexity is exponential. So I am seeing a lot of terms that might go over your head, but do check out the references later on. They will make it easy for you to understand the entire text. And finally, we have a centralized machine learning system. This is something that is new, which is coming right now. Uh, we are actually planning, not we as in the company, but it is actually there in the news that how we can actually integrate blockchain as a way to centralize and democratize artificial intelligence and machine learning model that we already have. How can we use that? That will be something that we need to watch out for, because blockchain, quantum, and in privacy, they are the future. At least for the next 10 years, they will be playing a very big part. So, study cryptography very well. And by the way, yes, quantum computing, there is a model that Mathis was also talking about, Shor's algorithm, that can actually decrypt or, bypass the current encryption schemes. But it is still not possible. We are a long way to go from there, but it is still there, and it might be difficult for us quite early. And then the last most important part is the ethics, right? You must have, I don't know whether you all are familiar with, but recently with the Black Lives Matter movement or the racial injustice system, it was a very difficult thing for machine learning, because the data that all these image recognition models were trained on was biased. There was not a lot of diversity in the data, and that diversity, the lack of diversity, was reflected in the models itself, right? And that is not a good thing. So ethics, when it comes to artificial intelligence, is a very, very big part, because the model is going to replicate or imitate your bias. the bias of the person who is creating that. Now, what I mean by bias, bias means in technical terms a opinionated behavior, an opinion, a predefined opinion on something, right? But in terms of machine learning, how I define it, it is an action that you take given that you have no knowledge or no prior knowledge, right? The baseline, okay, I know nothing, I'm going to do this. That is what is bias, right? You are automatically influenced to do this particular thing. Now there are a couple of things. First, data collection, right? Your data is private. I mean, in our country, Facebook, WhatsApp has recently changed its privacy policy, and we are having a lot of discussions about that. Whether people are making a move to Signal and stuff like that. Oh my God, data is not private anymore, and stuff like that. So that is important, right? How do you collect data? Whether it is even fine to collect data, because I don't know what if someone might be selling my data on what is that dark web for €5 or something like that. I don't know, right? So being able to actually securely work on the data that has been provided to you by the client, by the customer, by the person, whomsoever you're dealing with, is extremely important. Then comes my favorite part, adversarial attacks. Now, just like you have cybersecurity, hacking attacks, stuff like that, DDoS, denial of services attacks, we have adversarial attacks on models. Now, what it means is I am going to send such an input that your model will fail, no matter how good it has been trained on. So, what it means is if I give you an image of a panda and the model is originally able to classify that, okay, this is a panda, what I will do is I will tamper the image, I will change the pixels a little bit by adding noise such that the image by itself will not change. It will be a panda, but your model will not be able to detect. You can think of this as, I think, steganography, right? You hide a encrypted, you hide a message on an image, I guess. It is similar to that, not exactly, but almost similar to that. You change the image without actually changing it. And then you send it to the model, and the model is not able to predict. Now, this has very big consequences. Think about criminals, right? You detect the faces of someone. You can easily bypass the model, right? The model will not even be able to identify, oh my God, I cannot see anything. What is it? And there are cases like just if I put something here, the face recognition system will fail. So, and that is a very, well, I like it, but there are ways to actually work on that. And this is something that we are working on in the world. Researchers are doing that. Then is auditing. You need to check. You need to check your AI models from time to time, because what happens is people, for example, they don't check, right? They, okay, this AI model is available for free, I'll take it. It is available on GitHub for free. Who cares? People have said that, oh my God, I trained an AI model. You can use it. I'll use it. I don't know the data that it was trained on. I don't know whether it was a diverse data in the first place. And that too, who created it in the first place? What were the situations in which it was created, right? And whether there were checks, right? How can I make sure that the bias of the person is not induced into the model that he or she created in the first place? Then comes model development. Now, this is something that Google was under fire for, because, see, as the model gets bigger and bigger, you will be needing more and more GPUs. Take this thing as it is. GPUs are very important for machine learning, especially neural networks, and when it comes to images. And when the data becomes very big and your model is very big, you need GPUs because they offer you parallel computation abilities, right? The more you have them, the more electricity and resources they are going to consume, right? And that is not a good thing. So even though you are achieving good performance, there is an issue with the amount of carbon emissions, amount of resources that you're consuming. That is something that needs to be checked, because now we have all our companies, the intention might be good, but this is something that we all need to take a look at, and we are working to shrink the capability of the model as much as we can, so that there is lesser and lesser impact, lesser and lesser carbon footprint that we develop or generate while we are training the model. Then the last part, cloud governance and data monitoring. You need now, usually all the models, anything, whether your Google, if you have used Gmail, right? Google Photos automatically, tries to club up things, tries to identify photos and people in the photos. It is not doing it on your machine. That is happening on the cloud, right? It is happening on their server. So there needs to be a proper check. There needs to be a monitoring of what all data is being used of yours, right? And whether it is being given properly, because, or whether, right, if you have given heads up that, okay, take my data, whom all is your data being given to, right? Then who all are actually using my resources, who all are actually using my services, and for what purposes, right? I just cannot send out a model that, okay, you can use it, I am offering it as an API, but who all are actually using it, right? That is a very important thing. You need to take a look at that, because models, they are just like uranium right now. They can be used to make atomic bombs as well, and we don't want that. That is not going to be good. That is a moral choice that we all need to make. We cannot exploit the capabilities of artificial intelligence and machine learning, because they are capable of anything right now, and believe me on that. And the last part is data monitoring. Your data might be old, right? For example, yes, uh, the world is currently changing, right? There is more and more text that gets generated every day. You cannot train your model every day, right? So being able to identify when my model stops performing well in comparison to the data that we are getting, right? For example, if the documents or the web pages are continuously changing, your model has not identified that, is not able to capture that, that means that you need some retraining, right? So being able to monitor the data, how it is changing, whether we need a retraining environment, whether we are still fine for the next 2 weeks or not, that is actually important. More so, capturing only the data that is needed and has been allowed by the client or the customer, right? That, okay, you can take my photo, but not anything else. Now, I will leave on one important note. If someone wants to scrape your images, technically, even if you have your Instagram account, if people have used it is private, I can still scrape your display profile picture. If I just search for your name on Google, your profile picture will easily come. Now that is a difficult thing, right? Because there are so many sites that actually scrape out Instagram information, right, for hashtags and something like that, and they can easily scrape out photos. So nothing that you have is private anymore. As long as you're on the internet, your data is being used in one way or the other, whether it is images that you give for or not. Now, they might not be used directly, but whatever data that you give, it is going to influence the model in one way or the other. So just keep in mind that this field is very interesting. It is blossoming. And the next few talks that you will be having from machine learning, because I am not able to pronounce his name properly. It is after this, computer vision. Niharika and Joseph on the 4th, they are going to go into much detail about particular topics like computer vision, reinforcement learning, and how we actually do statistical modeling, right? Data science, and they are really, really important. I have laid a very basic foundation, giving you a high level overview of what you can expect, given that you're interested in these fields. And I hope you like it. And well, I think that's all that I have. There is one particular section that is left, but I think I will bypass that, because I would like to answer your questions, given that you people have any. Thomas, was I able to complete on time?
Yep. For questions, it will be a little bit short. So if people
Okay,
have
no.
questions, more on
Yes, yes,
Discord,
yes,
yeah.
yes.
So people, if you have any questions, we are going to send Discord server link, so you can ask questions to Siddharth there.
I don't know. Is there any question? I can't see anything. We will say that it's quite funny. Steg is live. They're talking about steganography, CTF
Yeah,
category of the day.
exactly. Yeah. So thank you, Siddharth. And the next talk is in 5 minutes. So I go
There are
quick on
really
this.
no questions. My God. I think I was too fast.
So I
Very
think
good.
I understood most of
No
it.
questions for me. That was clear. Oh my God. Thank you, Julian. I remember your name after you said so easy underscore. No questions for me. Thanks for the talk. Oh my God. What got you in AI? Oh, yes. See,
Yeah, Siddharth, try to do this really quickly because we have
yes, yes, yes.
right after.
What got me into AI? Yes, I have 4 minutes, right? If I'm not wrong.
Try to do this in 1 minute. Try
Okay,
to do
okay.
this in 1 minute. Thanks.
Yes, yes, yes. What got me into AI, Mr. Locksock? Well, first of all, see, the thing is that I like data, and you can easily find a lot of information about anyone or anything that you do, right? Underlying patterns, you can easily identify influence. And I'm a personal advocate of graphs, graphical structures, and machine learning and artificial intelligence. It allows me to understand the world in a in a different way, right? So that is what got me into AI. Very interesting. I hope I've answered your question. You can send me a connection request on LinkedIn. I am completely fine with that. You can ask me anything that you want. The presentation, I will be sharing the deck with you. IA plus OS int. I don't understand that. Sorry, Xanhax. I'm extremely sorry. I don't understand that. IA plus OS int. OSINT. Piero. I hope it was good. I'm
Okay,
extremely sorry.
so
I think that's it. I don't have any other questions because
that's great. Yeah, thank you.
that's it. Oh my God. Okay. Thank you. Thank you, everyone. Thank you for this opportunity.
Yeah,
I'll share the presentation quickly some other time. And open source intelligence.
yeah,
Okay. Zanhax, can you try to send this question to me on Discord? I
yeah.
will answer it there.
That is perfect.
Yes.
Well, thank you,
Thank you.
Siddharth, from
Yes,
your
yes, yes.
presentation. That
Yes.
was a great presentation laying the foundations of AI. So right now there is going to be a talk by Guillaume Saint-Cyr from the YouTube channel Machine Learner, who is going to present something about computer vision, which is a subpart of AI. So thank you, Siddharth, and see you after the break. Thanks. corner. Okay, so welcome to Guillaume Saint-Cyr. He is the Research and Development Project Technical Lead at GKN Aerospace and the founder of Machine Learning, a French YouTube channel specialized in AI. He is going to present to you how to develop your first computer vision program with Python. Welcome, Guillaume.
All right, can I go now?
Yeah, you can. Yeah, you can.
Oh, perfect. Sorry for that. Hello, everybody. So my name is Guillaume Saint-Cyr. Let me first introduce myself. So I'm a data scientist at GKN Aerospace. I've been working in London for 5 years now. For 5 years after my graduation at NSEM. It's an engineering school in France of mechanical and microelectronics engineering. And I've been working in the data science field for quite some time now. And today I'm going to show you how to develop your own computer vision system using Python and TensorFlow. I also have a YouTube channel and a website, Machine Learning, where I share with people tutorials about all these things: data science, machine learning, and deep learning. And it's in French. So let's dive into today's subject: building a computer vision program using Python. So first, what is computer vision? So it is a field of study that aims to automate the tasks that the human visual system can do, such as detecting objects, identifying objects. And these two things are quite different, by the way, because on an image, you first need to detect the presence of objects on the image. And once you've done it, then you can identify these objects like, oh, here's an object. What is it? Is it a cup of tea? Is it a bike? What is it? That's object identification. But it's not limited to these two things. It's also about understanding the 3D world we're living in, to, for instance, position the objects that we can identify, track motions, and so many different things. The applications include robotics, obviously everything related to autonomous cars, etc. Everything that has a camera in the system, basically. but it can be also quite specific, also specialized, I would say, like the analysis of X-ray images, automated inspection in manufacturing, which we'll see a bit later in the presentation, and many more applications. As I said, everything related to digital images, videos, etc. So how does it work? Well, the techniques have evolved quite a lot over the years. It started around 60s, 70s, where a lot of scientists created many algorithms that today are the foundations that we still use a lot for extracting edges from images, labeling the lines that we see, constructing shapes from these lines. And I really encourage you to have a look at some scientific papers like this one, A Computational Approach to Edge Detection from John Kenny, 1968. It's a really, really good paper. And here I'm showing you a few examples of different techniques to detect the edges of an image. You've got Sobel, Roberts, Prewitt, and so many others, like the one from Kenny, John Kenny, at the end. Well, in that period, what needs to be known is that the intent was to develop hard-coded programs that uses trigonometry or some advanced geometric things or image signal processing methods like Fourier analysis, etc., to actually detect shapes, etc., from the lines that we can extract. And unfortunately, that led to very little results because it's very, very difficult to hard code a program that can deal with millions, if not billions of different situations. So the results were definitely not very good. Once again, I really encourage you to have a look at this paper I've just mentioned. I'll leave you the paper on the Discord after the presentation, if some people are interested. So a few decades later, in the 90s, we had the first use of statistical learning methods for computer vision. Statistical methods referring to machine learning. So the baseline idea is that instead of computing some rules and using these rules on data to create answers like, yes, there is a cup of tea in my hand, what we do is we give a machine lots and lots of data, and we tell the machine what this data is or should be associated to, so that the machine understands itself the own rules to get the data to match the answers. And well, I think we've just had a very, very good presentation on AI just before me. So you must have heard about this, but I'm just saying that again. And we'll cover a little bit of that later in the presentation, just in case you're joining us now. So one very famous algorithm that emerged in the 90s was the eigenface algorithm. And once again, you have a very, very good paper, scientific paper. It's free. You can check it on Google Scholar. It's from Zirovich and Kirby. The paper is dating back from 1987, but really the technique was broadly used in the 90s. And that paper explains how to reduce the dimensionality of a data set of images to simplify the problem we're working on, so that the statistical method, the machine learning method that we apply on the problem can be more efficient. So really, once again, very good paper. Please check it out. Yep. So in the 90s, with these new techniques, we had a major improvement of performance in computer vision. But one thing that is required in statistical learning is a lot of data and a lot of image processing. And that's the issue with that technique, really, because at the time, we didn't have a lot of data, and we still had to hard code some image processing tasks like detecting the edges, maybe detecting a few shapes before giving this information to the statistical learning algorithms. So then, around 2010, we had the breakthrough of deep learning. That definitely changed the game. So deep learning is a domain of machine learning. It works the exact same way, and it deals with the development of neural networks. So neural networks are kind of special models. They are statistical models that learn from data. But what they do is that they are actually a network of nonlinear functions connected together and organized in layers, as you can see here. And the intent in deep learning is to get each hidden layer between the input image and the output answer, to get each of these hidden layers to do a little bit of task of pre-processing. And this is the intent of deep learning in computer vision. See, instead of having in machine learning a feature extraction task, like, okay, we detect the edges, we detect shapes from these edges, and then we give everything to a classification model so it can tell us what the image is. What we do is we give the image to the machine, it does all the edge detection, feature extraction, all that work, and boom, it gives us an answer. So actually that is the challenge, that is the idea. And we'll cover that in the presentation today. One thing to know is that actually these deep learning models already existed in the 90s. So why are we talking about these now in only 2010 and since 2010? Well, that's because deep learning requires a lot of data and a lot of computation power to perform well, or not really to perform well, but to learn well, because it doesn't need a lot of computation power once it has learned. Neither it requires to hold the data in memory, but it needs a lot of data in the learning phase. So that's an important thing to know. And since in the 90s, we didn't have either of these things, neither a lot of data or the computation power, well, we had to wait a couple of decades till now. So that is a very brief overview of the history of computer vision. I must tell you, there are hundreds, if not thousands, of techniques in that field. Fourier analysis, image filtering, so many different things, also including the technologies required to get the hardware to work well, the cameras, etc. But today we're only going to focus on the deep learning phase of computer vision, the one that we just mentioned in the bubble of 2010. So that's going to lead us to talk about machine learning, then convolutional neural networks. We'll do a quick demonstration using TensorFlow, and I'll briefly show you an industrial application. So let's start with machine learning. Just in case you're joining us, and you've never heard about machine learning. You didn't watch the previous conference, which was excellent, really. Machine learning is actually a field of artificial intelligence that aims to program machines so they can learn from studying examples. So let's suppose we have the following data that represents prices of houses against surface of houses. Our aim in machine learning is to develop a model that fits the examples we have in the best possible way. For instance, one model we can build is a linear model, like f of x equals ax2 plus bx plus c. And by the way, we say that a, b, and c are the parameters of that model. They are the values that define how the model is going to look like. So in machine learning, to get a good model, we use an optimization algorithm to minimize the errors in red between the model and the data that we have. So, for instance, what we see here on the screen is a pretty bad model because this model creates huge errors. So we use an optimization algorithm that's going to play around with all the different parameters, A, B, and C, until it finds the values of A, B, and C that minimize the error, such as this model, because this model has very little errors. It fits the examples quite well. So that is machine learning. And based on this principle, we've got lots of different models and lots of different optimization algorithms. We've got linear models with gradient descent. We've got support vector machines. We've got decision trees, lots of models, really lots of models. So now, how can we use this in computer vision? Well, let's see an example. Let's suppose that we have a data set of cat images and dog images. So two classes of data, two classes of pictures. And we want to build a machine learning classifier that's going to look at a photo and predict if it's a cat or a dog. So what we could do is take a photo, take these photos, and have a look at the key characteristics of the photos, like, for instance, the size of the ear, the size of the nose, and create a graph to put all this data, all the information that we have in our data set about the ear size and the nose size. And what we would see is, well, it's quite easy to build a classifier that separates these two classes using the principle we just learned, we just saw. We develop a linear model, f of x equals ax2 plus bx plus c, something like this, and that's it. Very easy. But the question is, how can we compute these two variables that we just used? The ear size, the nose size. We certainly need some pre-processing algorithm that does that job for us. And that's a bit tricky. So what about using the pixels of the photo as the input variables of the model? Like all the pixels of the photos, maybe the photos has, I don't know, thousands of pixels, we'll use the thousands of variables. That could be a good idea. Unfortunately, if we do so, we end up having a very complex data set containing thousands of variables, and it becomes really tough to develop a statistical model on this one, as you can see here on the screen. That is why when we use machine learning on image classification, we need to do some pre-processing, as I told you at the beginning. We need that feature extraction step, I would say. And this is why we are going to deep dive into deep learning now, because deep learning aims to include that feature extraction step inside its model. And we're going to see how it works now, talking about convolutional neural networks. So deep learning and convolutional neural networks, what is all of that? Well, deep learning is a domain of machine learning. It uses the same learning principle, as I told you, and it aims to develop neural networks. Neural networks are actually networks of nonlinear functions that are connected together and organized into layers. We just said that before. In fact, these functions, each of these functions, adjust their parameters to the data that we feed the neural network with, like the images of cats, the images of dogs, etc., using a gradient-based learning algorithm. A gradient-based learning algorithm is actually an algorithm that measures the gradient of the error, which is how the error of the model evolves as we move the parameters of the model. So does the error increase when we increase W11, or does the error decrease? So we're going to use such a gradient-based algorithm to minimize the errors. So to move into the direction where, to adjust the parameters so that we decrease step by step the errors of the model. And once again, a very, very good scientific paper that everybody should read is the paper that gave birth to neural networks. It's dating back from 1943 from Warren McCulloch and Walter Pitts. It's called A Logical Calculus of the Ideas Immanent in Nervous Activity. Sorry. Really good paper. I'll share it with you on the Discord afterwards. So how can we use this technique for computer vision? Well, in the 90s, a group of AI research specialists had the idea to introduce convolutional operations in the hidden layers of their neural network. So what is a convolution operation? Well, in mathematics, this is the definition from Wikipedia. A convolution is a type of operation on two functions that produces a third function that expresses how the shape of one is modified by the other. I know this sounds a little bit generic, but here's an example. A convolution in deep learning, in image processing, is actually a form of a kernel, like a 3x3 matrix, that we apply on the image to do some operation with it. And the results of such a 3x3 matrix, for instance, gives us the vertical images, the vertical edges of inside the images, sorry. And the same way, we've got horizontal filters, horizontal kernels, that when we apply them sequentially on the image, it returns all the horizontal edges in the image. So this team of AI specialists, led by Yann Lequin, produced this scientific paper, a very good paper once again. I know I'm presenting a lot of paper, but that's the essence of AI research. It's about reading papers, and those are the golden references. So it's very important to deep dive into those. And this is the paper that changed the game in computer vision. Really, I'll share it with you. But what these guys did was that instead of simply introducing these convolution operation, like, okay, detect horizontal edges, detect vertical edges, edges in the image, what they did was that they decided to let the machine learn what type of convolution it should use inside its network to pre-process the images. So in a way, this leaves the machine to decide what type of features it should extract from the image to make the best possible classification. And here's an example of the results of convolutional neural networks. So the machine learns how to filter the image, and all these images that you have on the screen are these filters that the machine found to be useful, to be the most useful, in fact. And using this principle, what we do is, instead of just building a neural network, we build a convolutional neural network where everything related to convolutions and another type of operation, which is pooling, which I won't dive into because it takes a little bit of time to talk about all this, and we just have 30 minutes. Well, all this is used to do the feature extraction bit of the neural network. And once we have extracted these important features, like what is the size of the ear of the cat, what is the size of the nose of the cat, well, we use this information to do our classification. Obviously, I'm simplifying a little bit all of this, but you've got the essence of it. So now, let's go and talk about TensorFlow. TensorFlow is actually an open source deep learning framework developed by Google and released in 2015. It makes it very easy to develop deep learning model, especially thanks to its high-level API, Keras. And we're going to use it today to develop a digit recognition program by training a basic convolutional neural network on the MNIST dataset. This is the data set that was used by Yann Lequin, who I just mentioned, to develop his first computer vision programs in the 90s. By the way, the code is available on my GitHub, but also, and I strongly encourage you to have a look at this, on TensorFlow's website, because I've just done a very basic convnet. So what we're going to do is first load the data, configure the model that we're going to use, train the model, and we will test the model. So to load the model, first, we load libraries like numerical Python, NumPy, for manipulating arrays and matrices, Matplotlib just to display some graphs, and TensorFlow and its high-level API, Keras. Then what we do is we load the dataset MNIST. We reshaped the data. We reshaped the data so it can accommodate the convolutional operations that are required in the model. I'm really sorry if I didn't dive into this in the explanation, but we need to keep it short. And we end up normalizing the data to facilitate the learning phase. So that means each pixel is normally on an image, on an 8-bit image. 8-bit makes values ranging from 0 to 255. So we want to squeeze down these values so they are between 0 and 1. So that is called normalization, and it facilitates the learning phase. So once we've done this, we can configure our model. So to do that, we use Keras API, and we add layers in a sequential model, like a sandwich. We start with a convolutional 2D, a two-dimensional convolutional operation. That is a 3x3 kernel. I'll skip these details, they're not very important. So that would give us something like this. Then we introduce a max pooling layer. Then we flatten the network. So we enter the classification part of the network. And we finalize with 10 neurons in the final layer. Each neuron will return us a probability for a given digit. So like 0, 1, 9, 2, etc. Then, once we've done all that, we can train the model. We call the compile method on our model, which is an optimizer. Just bear in mind, I was telling you that machine learning is all about using optimization algorithms. So we use an optimizer. We have a loss function that measures the errors of our model. And we can also measure not the errors, but somehow the opposite of an error, which is the performance, the level of correct answers. Once we've compiled our model, we can train it by using the fit function. That gives us the different answer, the different steps, just the learning phase. And after we've trained the model, we can test it. This is the code to do so. And optionally, we can also deploy it. I say optionally, but we always need to deploy a model somehow. So to do that, we can use everything we need. Depends on the situation. But one thing we can do is use the JavaScript version of TensorFlow to then deploy it online on a web page. So this is an example. So that is our quick demonstration. Once again, you'll have the code on GitHub and TensorFlow website. I'll also share it with you on the Discord page of the group. So to finish this presentation, let's have a look at some industrial application, or just one. So we can use computer vision, and I've been using computer vision over the last 5 years. I would only say 2 years in my current job to do some automated quality inspection, not only for 3D printers, but for any material that is produced in an aerospace manufacturing in an aerospace on an aerospace site. So what we do is, as you would guess, we take images, lots of golden labeled references of what's good, what is wrong. We feed that to a neural network that learns to detect well, errors or failures in the products that are made. That is a very quick example. I think we are a little bit short on time, so that's the end. I'll end the conference here. Just very briefly, if you want to learn more about computer vision for free, I would strongly encourage you to read the book called Deep Learning from E. Goodfellow. There's also the tensorflow.org website. There's my YouTube channel, but there are thousands of YouTube channels in the world. There's also this great book, Hands-on Machine Learning with Scikit-learn and TensorFlow from Aurélien Giraud. Is a very smart fellow who worked at YouTube for years. And also this book, Apprentissage Profond with Python, from François Chollet, who is the author of Keras, the library we just used for this conference. So really, these are excellent resources. I really encourage you to have a look at those if you want to learn more about computer vision and machine learning and deep learning, broadly speaking. So I'm ready to take a few questions. Thomas, do you know how to proceed, or shall I just pick questions on the chat?
So you can just pick questions and reply to them.
Okay,
Thank you.
okay. I read a few a few messages. That's PyTorch, sorry, is so higher than just all deep learning libraries. This is funny. PyTorch is another excellent library to do, another excellent framework to do deep learning. You can also have a look at this one. So, best book ever on deep learning. Yes, maybe you were referring to the one from Ian Goodfellow. Thank you very much. Thank you, everybody, for your messages. If you have questions, just ask your questions now. Thank you for all the thanks, and that was a very good conference, etc., etc. Thank you very much, but please ask questions. Okay, so a first question has popped. In maybe 10 or 20 years, where could these technologies be used? Excellent presentation. I don't know. I cannot predict the future, unfortunately. I think it would be used in everything related to, I mean, if we're now talking about computer vision, it's everything related to cameras. So autonomous cars, image generation, video games. We're already doing it now, but we will do it even better. Now, if you're just talking about AI, generally speaking, well, the fields are very, very broad. I mean, there are thousands of applications. I can't even tell, because 20 years, 30 years is so far away from now. Another question. What does your job look like on a day-to-day basis? So I'm a data scientist in the aerospace industry. I work in research and development, as well as a little bit in production. Obviously, in the aerospace industry, AI is not our first activity. It's not an activity at all, in fact, but we use AI to enhance or develop new technologies. That's what I'm in charge of, but also in production, because we've got automated quality inspection systems, for instance, that use computer vision, etc. So in my day-to-day job, I train a lot of models, I collect data, I try to solve problems, training models and interpreting the data. And obviously, and this is the case for most engineers, I have to write a lot of reports to explain what I'm doing, what I need to do, convince my fellow colleagues, etc. So many questions suddenly. So what about sound recognition? What are differences between computer vision and sound recognition? We do not use the same techniques at all, except both are today relying on neural network technologies. But in computer vision, we use convolutional neural networks quite a lot, and in sound recognition, we use sequence models, mostly recurrent neural networks. Now, there are dozens of architectures for these neural networks. You've got LSTM models, you've got what we call attention is all you need, all these things, but the idea is not exactly the same. You'll find a lot of very good references online. Again, please read scientific papers. That's the best thing to do, in my opinion. What studies did you do? I studied at ENSMM, an engineering school that teaches us general engineering. I've got a Master of Engineering, and I did a prépa CPGE. There was a paper on the method to reconstruct sound from the vibration of an object. Is it computer vision? Was a paper? I don't know, because I don't know what the paper is. And it doesn't ring any bell, unfortunately, for me. How is it to do research in deep learning? How do you do it? Well, I'm not a deep learning research specialist. I do not research new algorithms on nothing like this, because I work in the aerospace industry. So what I do is I use models that are already part of the state of the art. I tune them, and my work is on solving the problems of my business and not really working on new deep learning models, although I really would like to do that. Sometimes I do that at home after work, or I used to before I got involved with my YouTube channel, which takes a lot of time. What did I miss? You can always watch the replay. That is a good question, by the way. Can we fit in rainfall data? Sorry, I don't understand the question. If you can predict future, could some model do it? If you can't predict future, could some model do it? Yes, when I say I can't predict the future, I refer to the fact that I cannot predict what's going to happen in 20 or 30 years, mostly because I miss information. I would think that no model is actually able to predict such a future. I mean, what's going to happen in 20 or 30 years, unless they are trained on historical data. And one thing to know, and everybody should read the book Artificial Intelligence Does Not Exist by Luc Julia, where he explains that artificial intelligence models do not have a continuous domain of knowledge. That means when we train an AI model, it's only trained on a discrete task to perform. So one specific task to perform. So if we build a model to predict the future, it's only about what is it going to be like in terms of temperature in 20 or 30 years. That is possible. But we cannot say, okay, in the future, you'll have, it cannot perform it cannot perform a continuous range of predictions, unfortunately, or predictions on a continuous range of domains. Do you use MLflow or any tool like that for your projects? No, I mostly use TensorFlow, scikit-learn when possible, and then I write my own code using NumPy, SciPy, and that's just for the I would say initial phase. Then for the deployment phase, we always use things like AWS, which I don't personally use, but it's broadly used in my business, in my activity, I shall say. Docker, all these things. How did you learn machine learning? I learned machine learning when I was at the first year of my engineering degree in 2013, after I discovered that field in some work I had to do for my in my CPG years in prepa school. And I learned a lot from YouTube at the time, because there were I shall say little to no trainings online. So I learned a lot with YouTube, reading articles in the first years. At the time I learned TensorFlow or PyTorch did not exist, unfortunately. So I learned with initially C++. And when I moved to Python, I used Theano, which was the framework developed by the University of Montreal in the first years. And then as the years, with the years and more trainings, more and more YouTube channels, etc., coming online, I followed some trainings on Coursera. I read carry on reading papers. I really recommend people doing that, and books. Well, how much time do we have left for questions? I don't know. You tell me, Thomas.
Yes, you're the last speaker of the day, so you can take a bit more time if you want to.
Oh, really? Okay.
Yeah.
Hi, Guillaume. This is Lambert. What is the hardest part for you in computer vision? Oh, okay. Tough question. What is the hardest part for you in computer vision? I don't think it's AI. It's anything related to AI or deep learning, really. I think it's that is a good question. I never. Thank you for asking this question. I'll need to think about it, really. What is the to me? Perhaps it's only related to my experience, right? It's the project itself. It's not the deep learning side of things. It's more how to set up everything for the project, because that's what I'm often involved in my job. It's about getting the hardware to setting up the hardware, etc., setting up a system, because very often in my job, and by the way, that's not why that in this presentation I say I'm a data scientist, but in my real job I'm a little bit more than this. But I prefer to keep it simple, and and because it may sound a little bit pretentious and I don't like it, but I'm more of a technical lead, where in some projects I have to set up the entire system we're going to work on. And then, because I really want to, because I really like it and I ask to do so, then I do the deep learning side of things. This is my cake. I want it. But what's difficult in my job in computer vision is getting the hardware, the people. So it may be you may be disappointed by this answer, maybe, because it's not really technical. It's more the because what I do in my daily job is I use models that already exist for object detection. I use YOLO and so many different things like that are already existing in the state of the art. There's no reason to reinvent the wheel for someone like me, and I guess for 99% of the people working in deep learning, unless they work in research. But I don't work in research or in AI research. I work in aerospace research, so it's a bit different. Nice computer vision talk, by the way. It was very difficult for me to do that computer vision talk, by the way, because I'm used to have conferences that last 1 hour where I can take the time to speak. And here it was really like, whoa, we need to go fast. And I would have liked to do a little bit more of a explanation about machine learning and, not machine learning, but I guess convolutional neural networks, because I didn't have the time to explain max pool. I didn't have the time to explain that when we build a convolutional layer, actually we've got depth in the layer, these kind of things. But I don't think it's required. I don't think it's essential to get the people to understand the core idea, the core principle. Sounds are time series data, 1D, images are 2D data with only spatial information. That is well, that is not a question. That's not a question, but that is it's a little bit more. Everybody has a different people can approach these problems with different methods, different methodologies. You could say that sound is a time series data in one dimension. Some people do not approach the problem in this way, but in sequence to sequence generation, you could do that. Yeah, okay. Hey, how long is this live going to be? I don't have the answer. In some cases, we have missing rainfall data. Can we fill it with machine learning or with a model? Oh, yes, you can. You can check this. I know a paper that talks a lot about that. I'll try to find it and share it on the Discord after that. Is AI, AI can exist without man or woman? Oh, can AI exist without man or woman? I don't know. This is a philosophical question. I would love to discuss that with people, but not alone. And this is, I don't have the answer. When do you think Skynet will take over and send us back to the Stone Age? I don't have the answer to that question, sorry. I'm not allowed to answer that question, I shall say. AI is human-made, blah, blah, blah. What is your best advice for a beginner like me? So my best advice is for a beginner like you. I don't know, because there's no universal question. I get asked this question on a daily basis. Unfortunately, I don't have the answer because everybody's different. Everybody has a different background, different objectives. Everybody has different capabilities to learn new concepts, etc. So there is no universal answer, unfortunately. But I think the most important thing is understand everything you do. It's like in every other, it's the same for any other field, any other discipline. You need to really understand what you're doing. It doesn't matter if you don't go very far in your development, but get to a point where you understand the basics really. And nobody understands everything about. Nobody can master all these techniques. I'm personally not very good with, when I say not very good, like I could not have a professional job in things like natural language processing. No, because I'm not an expert. Because I've not specialized on this over the years, and I'm okay with this. So, and it's the case for everybody. No one can be a master in everything. Just pick up a domain and really master it. Start from the basics, start from the statistics, from probabilities, from linear algebra. You don't have to kill yourself learning these things. It can come over time as you learn machine learning and these things. But buy a book. That's a very good advice, in my opinion. Just purchase a book, study it. Don't read it, just study the book. Like take the book, take a pen, take a paper, and write what you read in the book. and practice a lot. Also, another very good piece of advice, join a community. That's very important. And when I started in 2013, as I told you, there were no community at all on the internet, or very little communities. And being part of a community really really projects you to the next level, because you can talk to people when you have questions. And there are great communities online. I'm personally very happy of the community that was created around my YouTube channel, because people are insane in that community. I don't own that community. I don't feel myself like I'm the boss. No, not at all. But this community is really good. There are other communities. One that was created around Thibaut Neveu's YouTube channel, very good community, and François Lambert Rosic community, very good, very good. Be part of a community. That's very important. I'll pick up the last questions. Is AI more powerful than human? I'm not allowed to answer that question. Currently, as AI is a tool and cannot make decisions. Well, it can make decision because it's trained to make decision. Now, it doesn't necessarily apply the decision, but it's used to do, it's used to do predictions. Now, it's still not a good idea, a very bright idea to use AI to follow AI in a blind way to take our decisions. No, I'm sorry, I got confused with decision and prediction. Robots will prevail. Don't try to resist. Thanks for your response. I can't read that. There's a marker in front of your message. It's not point of view. Do you think that computer vision needs to remove all our indicative prior on the subject, or that inducing good prior statistical physical in our algorithm networks graph is better? That is a tough question. It's the essence of deep learning to it's the original essence of deep learning to let the computer so in the data we collect, they are biased. The data we collect is very often biased. We can either clean that data or create an algorithm that does not take into account that bias. And the best examples are actually in natural language processing, indeed, where a few years ago, a lot of algorithms became that were used to develop chatbots became racists, etc. Very bad, obviously. And obviously that was because they were studying lots of documents around the world that had racism biases, sexism biases, etc. And it's very tough to eliminate these biases. But what we can do is develop algorithms that are orthogonal to these biases, for instance. And oh my God, I've missed so many questions, but I think the more I'm going to answer, like when I answer one question, 5 more questions are created. So it's not possible to finish.
I'm pretty sure about that. So thank you, Guillaume.
You're welcome.
I think the other questions will be on Discord, if the people are okay with it. So yeah, Guillaume will be able to reply to your questions on Discord, on the official Discord of the English Week. So thanks, Guillaume, for your presentation. Right now, there is going to be also Siddharth, who is going to answer for these questions, all right, for his talk about AI in general too. So thank you, Guillaume, for your presentation. That was a really good one. People were really excited about it. And see you soon. Thank you.
Yeah, thank you very much for inviting me. It was good fun. Thanks.
Thanks. See you and have a nice day. And now
Bye.
it's all. Yeah, goodbye. So, yeah, the music. So, welcome back, everyone, for Siddharth's questions about his talk. Feel free to ask any questions you have about his talk right now. We'll wait here for approximately 5 to 10 minutes if you have any questions. So, yeah, prepare to ask them.
Anything regarding artificial intelligence that you wanted to ask machine learning, but you were not able to answer, you were not able to ask, it is completely fine. Ask anything. One person was asking about GPT-3. Who was that? Thomas and I and some other friends of mine, I have had long discussions about that stupid model.
Yeah.
To be honest.
Really?
I forgot the name. Lawbiton, I don't know. I don't think so. They have any. They were all, my God. But machine learning, he took computer vision at a very good level. I mean, he was able to, I hope, and these people are really genius. They know a lot of things. I was assuming that they don't. That is, oh, okay. What do you do? Is that the same one, the Gildas GH?
Yeah, exactly. Yes,
Marketing
that's
person?
yeah.
Okay.
Exactly.
What do I do at IBM? Well, I do a lot of things actually. The thing is that the roles are not defined. The role of a data scientist is multidisciplinary. So I had a project, not a project, but a POC. POCs are smaller than a project. They are usually for 6 to 8 weeks. So that I had, for which I was supposed to do natural language. I was working on natural language processing. So we were supposed to basically compare whether a particular text was present in a document or not. So it was a searching task, but the text could be in a different manner. So semantic matching was also to be done. So we are working on that. Currently, I am working with Azure. We are supposed to create assets, or what we call as toolkits, for natural language processing on Azure cloud as well. So I am working on that. That is a 5 to 6 months project that I'm a part of. It started yesterday. So there is no hard and fast rule. We work on the latest technology though, because we have to, but there is no, as in, the way, for example, I forgot his name, machine learning, he was working with computer vision, right? We don't have that. I can work on analytics depending on the project. I can work on computer vision depending on the project. I can work on NLP. There is no restriction for us. How did I get into artificial intelligence? First of all, my specialization was data science. It was not even artificial intelligence, and I still don't understand how did I get into that. But I don't. Mostly these fields are actually statistical fields, right? So as long as you're interested in statistics, pure machine learning, pure mathematics, because we use mathematics on a daily basis, and that is what got me into artificial intelligence. And as I said before, it is a very dangerous field. You can use it to do whatever you want, and that is what I want to do. Someone said that they want to lead the world. Well, that is also my plan. I too want to lead the world, if possible, using artificial intelligence, but who knows. Anything else regarding artificial intelligence? Not, do you think you will work on AI forever, or will you change the IT field? Pierre O. Technically, see, AI is a very, I'm not working in the research domain, right? So for me, I have to read papers, I do research, I develop at the same time. I even need to understand the business side. So technically, I am doing a lot of things at the same time, as in all the data scientists at IBM here. So I don't think so that I will shift. Although I might get into teaching, I don't know if I don't like working anymore. So that is something that is there. Anything else you want to know about artificial intelligence? Anyone? I think we are almost there. I don't think so. Machine learning. I hope to watch the result. Thank you so much for coming. No, I don't think so. Any more questions? Since you work on NLP, have you taken a look at BERT? Actually, we used BERT. We used Distil BERT in my POC, the project. What is your question, Yari and Kiva? What do you want to know about BERT? It is a very useful model, but I mean, someone was asking about inductive bias. Graphs don't have that, and transformers actually use that only. And that is why they are able to perform that well. So Yarian, if you can ask a targeted question, it will be good. What is a typical day of an ML engineer? Well, technically, right now, since I'm working from home, it is mostly sleeping because the timelines, we do have deliverables, so it is up to you when you can work. But on a usual setting, it is usually looking at the screen and waiting for one meeting to end and go for another, because there are a lot of meetings and we have a lot of projects that overlap, right? So it is not like, they show that, oh my god, I'm just coding. We code, we develop at the same time, and we do need to give time for research as well. So it is a mix. It is not that heavy as a software engineer would do, because ours is very much divided. We don't do everything. Is there a model you are working on right now? By model, I mean an interface to interact with a particular type of AI face recognition. Yes. Some things are a little bit, we cannot tell you, it is confidential work, but we are working on something. We are coming up with a new approach for our particular use cases. So cannot tell you, but yes, we are working on. There is no stopping, right? We are always working on one model or the other because the use cases never end. So from an industry point of view, some things just cannot be disclosed. That is something that I learned very late, but that is the case. So I can't tell you, but yes, we are working on multiple models, and that work continues. Okay, you answered my question without me having to ask. Thanks. Okay, was it about inductive bias? But okay, is there anything else? Thomas, how much time do we have left?
As much time as you want. I mean, we can wait for 2 minutes if
Don't
people
worry,
are.
we are only 56 people listening. My God. But seriously, you don't have anything, any question to ask someone? I mean, it can be very vague as well. You can ask me anything as long as it is related to AI. You want to ask dangerous question about that, I'm open to answering, because I had a talk with someone regarding that in the afternoon itself, whether AI is good, we will have superhuman intelligence or not, something like that. So anything you want to ask. Hmm. Jack Crimson, I don't think so there is any more, because
Yeah, since
these
you
people are
told
very...
us about quantum computing,
Hmm.
um, what do you think?
Quantum.
Yeah, quantum. What do you think AI can bring to quantum, and what does quantum can bring to AI in both sides?
Okay, now that is an interesting question. Uh, I will answer your question after I answer these. Okay.
Right.
Do you think AI will be dangerous in the future? How do you deal with bad data set? No, I hadn't thought about that, Pierre. Oh. Okay, first of all, do you think AI will be dangerous in the future? First of all, no. AI can. This example I have given it many times. See, when uranium was discovered, right, no one knew that it would be used to make an atom bomb. Okay, but still people went out, they bombarded Hiroshima and Nagasaki, and people died. So we don't know whether people will be using AI for, uh, you know, ingenious purposes or dangerous purposes. We don't know any idea. We can just hope that it will not be. But there is a belief that I hold that sooner or later, given the way we are progressing, we will be able to create something that we did not expect before. Just 2 days ago, that is what I was sharing. Machine learning, he was talking about a particular thing, right? That we have discrete outputs are not continuous right now. So the thing is that some scientists, I think at MIT, they have developed liquid neural networks, right, which can act, which are specifically for time series. That is, they can learn on the fly, right? So whenever they will learn while you are running it itself. So not only during training they will learn, but during the testing or running, whenever any input comes, they will learn then as well. So we are changing the way we approach neural networks. We are changing the way we approach machine learning in general. So I hope that answers your question, Chor FMI. Then Nureni, how you deal with bad data set? First of all, you cannot deal with it in the first place because there is a threshold, right? How much can you lose, right? Because if most of your columns are empty, you don't have any information, then what will you do? For example, for us, we had to literally go after our client to get the data in the first place. Like we did not have ground truth, right? So we asked them that please give us ground truth so that we can actually validate whether our performance is good or not. So data set, as long as you have the information you need, it is not bad. It only becomes bad when there is nothing you can use and that data set itself is wrong, right? You don't know how it was created. So it was created, with different ways, as in the people who created the data set, or who were inputting the values, if they were lazy, they did not do their work properly, then the data set will obviously be bad, right? So that is something that you need to take care of. It is basically, you have to think where you buy your ingredients from. If you're making a dinner for your date, you don't want it to be bad, so you have to be cautious. Okay, buy from the best shops, buy from the, someone you trust. The other question from Piero: since you talk about nuclear bombs, do you think AI will get to the point where humanity won't want to use it anymore? See, to be really frank, artificial intelligence up till now, it has made our life easier, right? And we don't know what is about to come in the future, right? People already talk about existence of aliens and all. There are those, what is that? The conspiracy theories that, oh my God, aliens are amongst us, those stuffs. You really don't know what the future holds right now, right? So it can go anyway. It can even end up ending us, or we might be able to use it in a better fashion actually to understand us, right? Because artificial intelligence or the machine learning models that we have, they have the capability to discover patterns that we did not think existed before, right? And recently, with what DeepMind has done with the AlphaFold regarding prediction of protein structure, it is outstanding that what AI can do. So we can only go ahead from here, right? People will exploit it. It has been the case with any technology, but it is surely, hopefully, it is going for the best. It is, we are going in a good direction. Now, answering Thomas's question regarding quantum. Quantum right now is a very, very, very important field because it is going to, we are very far from achieving supremacy or actual good results, but quantum poses threat to cybersecurity. If but this has a very low probability, but if quantum is, we are able to achieve good performance, all the cybersecurity systems, they are about to break because of something known as Shor's algorithm. It can easily factorize it. This is what Mathis was talking about in the morning when we talk about encryption, right? Encryption is purely based on prime numbers and factorization, the RSA algorithm. So if quantum is actually able to do that, then we will lose out on security. But then quantum encryption and quantum cryptography are taking up. When it comes to machine learning, quantum is still being explored. Why we are, because it is a new way of computation, it is a new domain. We still don't know whether it will actually be applicable to a very big extent. It might not break everything, Pierre, because we don't, it is, you cannot have them. I mean, the scale at which the computation we have today, I the it will still take a lot of time, right? Because quantum, there is a issue with noise. You need there are, for example, IBM is using a different way to create qubits, which are the smallest using unit of quantum computation. Then similarly, Honeywell or IonQ, they are using a different methodology, right? I think they are using photons. So because they are using different methodologies, there are pros and cons to related to their ability, right? So till now we have some good things, and the best part where quantum will be able to help us is in combinatorial optimization problems. What are they? If you must have heard of traveling salesman, all these NP hard problems which are exponential in nature, they can actually be solved, or at least we can try to solve them using quantum systems. That is what my assumption is, because I don't know if you are all are experienced or have an idea of a complexity theory. Most of your problems, they are polynomial in nature, as in they can be solved within n or n square, something like that, in that time interval. But graph problems especially, they are factorial based, right? You need to consider all possible example, all possible cases to actually do something. For example, the traveling salesman problem, what does it say? That if you have if you have a map, right, and I want to particularly order something, right? I want to deliver something. What is the best possible route that I need to take? So you need to find the best possible path, right? Now you don't know what is the best possible path unless and until you check every single path, right? So it becomes factorial and exponential in nature. And we don't have current solutions. I mean, we have approximate solutions for that, but we don't have good solutions like we are, which are actually very fast. So quantum is one area which actually allows us to work on exponential problems, because of the way that they actually assume that everything is working simultaneously. The states are 0 and 1 at the same time, right? So you can actually operate on all of them at the same time. So that is there. But it is still an open field, and it is really interesting, and you people should, some of you who are actually interested, they should actually work on it. try to go into it if you are interested. Research. IBM does have. I mean, we have a Qiskit library. We have our own library for that, for modeling, and it is available for everyone. They can simulate quantum circuits on Qiskit, and quantum experience. It is available for free. We don't charge, and that is something that is actually not done by anyone. So you all should definitely check it out. Apart from that, I don't think so there are any questions regarding AI or something. Piero. Who is this Piero? This is such a funny name. Pierre. We have a pen named that. Does AI one day replace data scientist jobs? You are scaring me. That is some fear that I have, that it will take my job and I will not be able to do anything. But the thing is that if that is possible, then I will happily create that, because when one job is actually destroyed, few new jobs are actually created. Data science role is, as long as AI, well, this is a good thing. AI will not be able to reason until the next 10 years. So my job is secured. But after it is able to do that, I will be in great problem, because then I have to train that AI to make decisions like me, which is certainly not possible right now. So no, it will not be able to replace data scientists. It will always, this is what we at IBM, we don't call artificial intelligence, we call augmented intelligence. That it will always, it should add to the intelligent ability. Right. So that is what it will be doing. AI will actually become the best accelerator that we have in our search for truth, or in our search for discovering what is there in the universe. Recently, I did not include this in my talk. People have been working on differential equations. Partial differential equations have become a very hot topic when it comes to artificial intelligence and being able to solve them using that. So there is a lot of work, and it was done by Caltech people. They were able to, I think, formulate Navier-Stokes, the flow of that. And Navier-Stokes, I think, is one of the most, it is one of the problems from the Clay Institute that needs to be solved. Right? There are 7 problems. One, the Poincare conjecture was solved. The other 6, I think, still remain. And Navier-Stokes is one of them. So they were able to do something related to that by by creating a partial differentiator operator. They were able to simulate the flows of fluids. So there is a lot of work that is actually happening, and it will be helping us in our search for newer things. How can we access the different replays of the English week, please? You can actually, if you once this is actually over, if you click on the English week link, right, it will show you both the clips separately. So I think they are available for 15 days, right, Thomas?
Yep,
15, 16
exactly,
days.
yeah, exactly. And we'll
Yes.
save them for even more
YouTube.
time, yeah, for a lot of time. And then on YouTube, yeah, exactly.
Yes.
All
What is the
right.
time there?
The time there is 6 p.m. and 20 minutes.
Okay, we'll take 5 minutes more. Sorry.
Yeah,
5 minutes, last 5
even
minutes.
2 minutes. I
Just
think that,
complete it, because I need to go
yeah,
after
I
that too.
think the people send us
I
all
don't
the
think so they have
questions.
anything else.
So yeah,
Yeah.
it is okay. It is really good. If anyone else has questions, they can go on Discord if they want to and ping
Okay,
Siddharth.
yes, that is also fine.
So
I
thank
don't
you,
think so
Siddharth.
they have anything.
Yeah,
Ask the speaker, someone has. Oh, he shared the Jan Lekons. Yeah, great invest.
yeah,
Document.
thank you.
That was a very nice paper.
Perfect.
Why is he sharing mixed
Uh,
virtual human? Oh, yeah, dance one.
and thank you, Siddharth, for your
No
presentation.
problem.
Yeah, and see you and have a nice day.
Yeah,
We will continue the English week
on
by
4th.
exactly on 4th by Thursday, and with topics about AI, about cybersecurity, and video game development. So if people are interested into this,
Yeah,
and
they are actually very important. Okay, so
exactly, yeah.
whatever machine learning I has said, just
Yeah.
keep that in mind.
So,
Everything
so
is used.
thank you. Yeah.
No
So
issues.
thank you.
I'll go
Have a
in.
nice day, and
Thank you.
see you Thursday for the next talks. Thank you.
Yeah,
See you soon.
only if I'm free that
You will be free. I know this. See you.
most
Bye.
cases.
Have a
Okay,
nice
bye
day.
bye. Take care.
Thanks.
Thank you, everyone.
Bye.